Okay, let's talk about the term you've probably heard everywhere lately, generative AI. I mean, in just the last couple of years, it has absolutely exploded. It's gone from these obscure research labs right into our daily lives, with tools like ChatGPT just completely capturing the world's imagination. So what is really going on under the hood?
To really wrap your head around just how big this moment is, check this out. It took Google Translate 78 months to hit 100 million users. TikTok, which felt like it was everywhere overnight, did it in 9 months. And ChatGPT, a mere 2 months. I mean, that kind of speed is it's unheard of. It's a massive blinking sign that something truly different is happening right now.
And trust me, this isn't just media hype. The researchers who are actually building this stuff, they believe we're at a major inflection point. As one survey from 2023 put it, all this progress suggests a whole new era of AI is dawning. So yeah, understanding this technology isn't really optional anymore. It's pretty much essential.
All right, so let's dive into what we're calling the AI Big Bang. We're going to unpack what's behind all the headlines and really get to the core of what this technology is.
So what is it that makes generative AI so different? Well, you're probably used to AI that analyzes stuff that already exists, right? Like it can tell you if a photo has a cat in it, or it can translate a sentence. But generative AI, it creates brand new things. Entirely new images, new songs, new essays, all from scratch.
So how on earth does it do that? You might be imagining some incredibly complicated, abstract thing going on. But the truth is, this whole revolution is powered by a surprisingly simple idea. At its very core, a huge language model, the kind that powers ChatGPT, is basically just a really, really sophisticated next word prediction engine. Seriously, think of it like the autocomplete on your phone, but scaled up to a totally mind-boggling degree.
And the way it's trained is actually pretty intuitive. You start by basically letting the model read a giant portion of the internet. Books, articles, websites, you name it. Then, you play a simple game with it over and over. You show it a sentence, but you hide the last few words. You ask it, hey, guess what comes next? When it gets it wrong, it adjusts its internal wiring a little bit and tries again. Now imagine doing that billions and billions of times. Eventually, you get a model that has an incredible feel for the patterns of human language.
Okay, so a simple prediction game. But how does that simple game create these monster models that we hear about? Turns out there was a specific technological key that had to be found to unlock this whole thing. And that key was a neural network design called the transformer. When it came out in 2017, it was a complete game changer. Its secret sauce is a mechanism called self-attention, which basically lets the model weigh the importance of different words in a long sentence. This is crucial for understanding context. Plus, its design made it possible to train on a massive scale, way faster than ever before.
And when I say scale, I mean wow. Take GPT-3, one of the models that really kicked this all off. It has 175 billion parameters. You can think of each parameter as a tiny little knob that the model gets to tune every time it learns. And something amazing happens at this kind of scale. Abilities that nobody programmed in just start to emerge. The model doesn't just predict words anymore. It starts to show it can reason, summarize, and even write computer code.
But here's the thing. A raw model that's just read the internet is a bit of a wild card. The internet's a messy place, right? That's why the second step, alignment, is so important. Using a process with a mouthful of a name, reinforcement learning from human feedback, developers fine-tune the model. Basically, real humans rate the model's different answers, teaching it to be what the researchers call helpful, honest, and harmless. This is the step that turns it from a raw know-it-all into a genuinely useful assistant.
Now, even though chatbots get all the attention, this generative revolution is happening in so many other places, way beyond just text.
I mean, just look at the landscape. Of course, we have incredible text generation with models like GPT-4, but then you have stunning images being created by models like DALL-E 2 and Stable Diffusion. We've got AI composing original music, synthesizing realistic voices, and now we're even seeing the first text-to-video and 3D model generators. It's the same core technology, just popping up everywhere.
And the stuff it can make is just mind-blowing. These text-to-image models can take a simple phrase like an astronaut riding a horse in a photorealistic style and, boom, seconds later, you have a high-quality picture of something that has never existed before.
This is also totally changing technical fields. Models like Codex, which is the brain behind GitHub Copilot, can take instructions in plain English and just write working computer code. It's like having a programming partner right at your fingertips 24/7.
So the technology is powerful. It's spreading like wildfire. But, and this is a really big but, all that power comes with some critical challenges that we absolutely have to face.
You know the old saying, with great power comes great risk. This is an incredibly powerful tool. But what are the downsides? What happens when this power is misused, or even when the technology just makes a mistake?
And the challenges are pretty significant. First, there's factuality. These models are designed to be plausible, not necessarily truthful. So they can hallucinate, which is a nice way of saying they confidently make stuff up. They can also soak up and amplify all the nasty biases from their training data. And in high-stakes fields like medicine or finance, a mistake isn't just an oops, it could be really dangerous. Oh, and on top of all that, there's the environmental cost. Training and running these things takes a massive amount of energy. The potential for misuse here is just alarming. In one test, an organization called NewsGuard fed ChatGPT 100 known misinformation narratives. It churned out convincing, authoritative-sounding, but totally false stories for 80 of them. 80%! This technology could fuel misinformation on the scale we've just never seen before.
And this isn't just theoretical. There was a model called Galactica, designed specifically for scientific information. It was taken offline after just 3 days. Why? Because it was generating biased and just plain wrong results, but it was doing it in a very authoritative tone. It's a perfect, stark reminder that with these systems, confidence does not equal correctness.
So all of this leaves us with what might be one of the defining questions of our time. We've built these incredibly powerful engines for generating content, and they are transforming everything. But can we build the guardrails? Can we find the wisdom to make sure that what they generate isn't just plausible, but also truthful? The answer to that question is going to shape a whole lot of our future.